4.8. Newton's method. This method will, with the use of calculus, will enable us to solve any equation you can ever think of. So, let's say I have this function. It's a continuous function. No, it's not our best friend from day one. It's just a function having an x-intercept somewhere. So let's say this is the x-intercept. I'm going to call it r root, or call it c, call it anything. It doesn't matter what you want to call it. And let's say, using the intermediate value theorem, because the function is continuous and it changes sign on this interval, let's say between a and b, I find out that there is an intercept. I'm trying to solve the equation f of x equals 0. And I find that f of r is 0, but I don't know what r is. The intermediate value theorem will say, function is continuous, it changes sign, we know this from a long time ago. The function changes sign, it's continuous, negative is on this side, negative on this side is positive. So obviously it has to go through 0. Okay. Here is the mechanism. I consider this the initial value. You can say, what if we consider a the initial value? Any of those two, it doesn't matter. On a unit interval. If it's between 1 and 2, you can start with 2 or you can start with 1. It doesn't matter. Let's say we start with b. We will draw a vertical line. It meets the graph in a point. I'm going to call it P, but it has nothing to do with the others from our past. I am going to draw a tangent at this point that I will extend and it will cross the x-axis at this point. So this is my initial value. I'm going to call this point x sub 1, comma, y coordinate 0. I have this point that has coordinates x0, comma, f of x0, bless you. And I would like you to give me the slope of tangent at P. The slope of tangent at P in two different ways. Remember, the tangent goes to these 2 points. You have 2 points. Please tell me how to find the slope of this tangent. And also another way that we've been using the entire semester, almost.
P over b minus x sub 1.
F of x0 minus 0 over x0 minus x1. We agree? F of x0 minus 0 over x0 minus x1. Would you agree with that? Y2 minus y1 over x2 minus x1. Right? Rise over run. But there is another way, and I would like you to give me the other way. I hit everything tonight. It's the tangent at P. How have I determined the slope of the tangent at P? Yes, f prime of f prime of f prime of right? F prime of x0, right?
Oh, right.
So this is f prime of x0 because the x of P is x0, right? Would you agree with that?
Yeah.
Good. Let's cross multiply. So I have x0 minus x1 times f prime of x0 equals f of x0. And you should say stop. Stop. What are you doing? think I'm after? Before you say it, let me give you a hint. I started with x0, saying to you, x0 is an approximation of R. But now, I found x1, which is a better approximation of R. Then I continue the process, going up, creating the point Q, drawing a tangent at Q that will cross the x-axis x sub 2 comma 0, and obviously x sub 2 must be a better approximation, even better approximation of R, because it's closer to R. And I can continue like that forever, and I will eventually get very, very close to R. So in this equation, after I set equal the two slopes in two different ways, what do you think I'm after? It looks like it, yes. But what exactly, because it's a tangent, of course. But what am I after from here? This, I know, I picked. This, I know, because f prime with the number that I picked. This, I know, it's f, and I plug in x0. So what am I after? Of course, I'm after x1. Why? Because x1 is a better approximation than what my starting point is. And then the next step, what do you think I'm going to be after? Of course, because that's going to be even better approximation. And then what do you think I'm going to be after? Perfect. So let's solve for x1. So we have x0, f prime of x0 minus x1, f prime of x0 equals f of x0. I will move this here and this here. So x0, f prime of x0 minus f of x0 equals x1, f prime of x0. And finally, x1 will be x0 minus f of x0 over f prime of x0. Can anyone without any calculations give us x2 and later x3? And this is Newton's method. So all I did was, this is a linear equation. I solved for x1. I distributed. I moved the terms around to get x1 by itself. And I divided by f prime of x0. So I get x0 minus f of x over f prime of x0. So can anyone draw a conclusion? What will I get for x2?
x1 minus f of x1 over f prime x1.
What will I get for x3? x2 minus f of x2 over f prime of x2. In general, I continue forever. X sub n plus 1 equals x sub n minus f of x sub n over f prime of x sub n. And this is the general Newton's method. Newton's method. How did we get this? Setting equal to slopes. It was brilliant. They didn't have calculators. That's how they did it. That's how they found solutions. Okay, so then, two potential problems here. One is, remember we pick x0, or x sub 0, or x naught. What could be the problem? And f prime of x sub 0 is, yeah, so you have to be very careful. Make sure that the number you pick as the starting point does not create or make f prime 0, because you're never going to get anything. The second potential problem is, if the solution is here, and you start here, and the function has a max or a min between the initial value and the solution, the method will never converge. It will stay here, it will never get to the solution. But that's very rare. That's a very rare situation. Okay, so now let's apply this. Choose any equation. Now you're capable of solving any equation, anything. something that you had no idea you could. So for example, no one can solve this by hand. No one can solve this by hand. No one can solve this by hand. Maybe this one, possible. Maybe this one, possible. This one, no one can solve by hand. None of these can be solved by hand, by any person. They can come up with some approximation, but not algebraically. No, not algebraically. So, I'm telling you. Okay, so this is one option. You could like this, you could like this, whatever you want. Which one? You said 22? Okay, yes? Very good. Good, 22. This is on page 342. So 22, 342. Okay, so this is sine x equals x squared minus 2. Of course, like before, I have to create the function. I have to name it. And I have to say that f is a continuous function. Everywhere. As different sums of continuous functions. Everywhere. On negative infinity to infinity. And number 2, I have to plug in the function in the graphing calculator and find an interval. I have no idea where it has a solution. So I need an interval, a 1 unit length interval. So in y equals, we clear what I did with my pre-calc today. So then sine x, make sure the mode, and I worked with them on some angles and stuff, so please make sure the mode is in radians. So sine x minus x squared and plus 2. Start from scratch. Sine x minus x squared plus 2. I was going to say, it's right there. You should. Very good. So now we plug in second and table. So I'm going to plug in 0, 1, 2. Ah, I got it. Between 1 and 2. So f of 1 is positive. F of 2 is negative. So therefore, by the intermediate value theorem, there exists a solution. There exists C, in this case it's R, doesn't matter, in the interval 1, 2, such that f of R is 0. We are after the root R, or the solution R. In step number 3, we create Newton's function. Newton's function is x minus f of x sine x minus x squared plus 2 over f prime cosine x minus 2x. This is the function we are going to put in the graphing calculator. And now you have to give me an x0. You have to choose an x0. Is it 1 or is it 2? It doesn't matter what you pick, because cosine 1 radian times negative 2 minus 2 is not 0. If you say cosine 2 minus 4 is still not 0. So it doesn't matter. I'm fine. You can choose whatever you want. But you have to choose. Is x0 your initial value 0 or 1 or 2? Doesn't matter. Okay, we choose 1. Now I want accuracy. How many decimal digits you want? 4, 6, 7, 8, you name it. Whatever you want. It's not going to be exact. It's an irrational number. You're not going to be able to find a solution. But you're going to be as close to it as you wanted it to be. 4 decimals, 6 decimals, what do you want? We want 4? Good. Accuracy, 4 decimal digits. Perfect. So let's put the function in, please. Do not delete what you have. So go to y equals do not delete, because you need to type it in again. So let's insert x minus parentheses for the top, close the parenthesis, after sine x minus x squared plus 2, close the parenthesis, and divide in parentheses by cosine x minus 2x. Close the parenthesis, minus 2 times x, close the parenthesis, and after you're done, get out of there with second and quit. Please second and quit. Okay. After you're done, go to variables. Cross to the right to y variables. Call the function. We put everything, I put everything in y1. I don't know if you put everything in y1, but if you didn't put in y1, you call the function where you have your Newton's function. I plug in 1, and I press enter. What is this? What does this represent? X, we did x0. X1. That's our first. So now you have to be very careful. We're expecting a solution between 1 and 2. Oops. Now I have to watch. Because if the next one is -5 and the next one is +10, something is terribly wrong. Maybe when I put in the function, who knows? Be very careful. So this is a little bit outside, right? But it's still x1. That's fine. I'm copying it. 2.26154. Here's what I do next. We copy what we see, but we overwrite 1 with the previous answer. And now please tell me what this is. Much better. What is this? X2, 1.80733. Moving forward, all you have to do is just copy what you have and press enter. What is this? 1.73087. I copy. What is this? 1.7284687. I copy one more. And I don't have to do anything anymore. Do not copy the last one. You said 4 digits. 7, 2, 8, 4, even 6. So you don't need the last one. So according to what you picked, the approximation, you said 4 decimal digits. That's all I need. And that's Newton's method.